Hello everyone, and welcome to the Digital Forensics and Incident Response Webcast. What's new in REMnux version 4 for malware analysis? I'm Benjamin White with the SANS Institute, and I'll be moderating this webcast. Today's featured speaker is Lenny Zeltser, Senior Faculty Member of the SANS Institute and Product Management Director for NCR Corp. Before I turn things over to Lenny, the Q&A portion will take place at the end of the webcast. Please feel free to submit your questions at any point by using the chat window. Right now, I'd like to introduce our featured speaker, Lenny Zeltser.
All right, thank you very much for the introduction, Ben, and thank you everybody for joining. I'm very happy to talk to you about REMnux because, well, I love tools, and there's a whole lot of new tools that have been added to the latest version of this distribution. Now I'll be showing you lots of screenshots, lots of command line parameters, and lots of live demos. We'll be going relatively fast, but don't worry because you will be able to download all of these slides and all of my speaker notes and all of the hyperlinks and everything else. You'll be able to download them as a PDF file about an hour after this webcast ends. So don't worry if we move a bit too quickly for you to be able to write everything down. Not only will you be able to review the recorded version of the webcast, you will also get access to all of my speaker notes. All right, so I want to talk about REMnux, and of course REMnux is the Linux distribution that I put together. The idea is to have a bunch of tools that are useful for analyzing malware and make it easier for people to get into the world of malware analysis because you don't have to install these tools, you don't need to find them, you don't need to configure them. That's really the biggest benefit to REMnux that I can find. Now all I did is I started with Ubuntu version 11.10 and added a bunch of tools to it. The full credit for all the wonderful usefulness of the distribution really goes to the authors of the tools. I just put them together. But there's a whole lot of tools to keep track of, and that's why I put together this webcast to focus specifically on those tools that have been added to REMnux in the release that came out in early April. That's version 4 of the release. So I wanted to review with you what are the major changes and also what are some of the tools and how do you use them. But if you're new to REMnux, you can certainly download a copy of REMnux on remnux.org, and also you can tune into a webcast that I recorded previously. I'm sure you'll find it on Google if you look for malware analysis essentials using REMnux. All right, so let's see, what's the best way to get started? The best way to get started, I think, is for me to drop you into my REMnux virtual machine so that I can show you a bunch of things. Again, I'm going to be spending a lot of time in that virtual machine during the webcast, but don't worry because you'll have screenshots and everything in the PDF file that we'll make available to you. So what I did here is simply download a copy of the REMnux virtual machine. And one of the new things in the latest distribution of REMnux is how you can download the virtual machine appliance. Before, REMnux was available either as an ISO file for a live CD or as a proprietary VMware virtual machine. I'm also now making it available using the open virtualization format, which makes it easier for you to import this virtual machine into lots of other virtualization tools, most notably VirtualBox. So now it's much easier to use REMnux on VirtualBox. What I did here was simply load up a copy of the REMnux virtual machine, and I'm going to start it up for you. REMnux ships with host-only mode to limit network interactions, but for this webcast, before starting it up, I'm going to turn on NAT mode because I want to have access to the web so that I can, well, download a few tools and updates, if you will. I'm going to show it to you shortly. So, what kind of tools do we have here, and how do we make use of them? Well, I think it's much more enjoyable to talk about tools in the context of actual real-world malware. So what I did was put together a bunch of malware samples that I'm going to use throughout this webcast. Let me get them here. You can get these samples as well if you want. Here's the URL. Now, the password is the word, wait for it, fruits. So anybody can download these samples. Just be very careful with them because this is real-world malware that we're dealing with here, and that's why password protected with the word fruits to avoid accidental execution. All right. Now, let me take you for just a couple of minutes back to my slides. I wanted to mention a few things regarding how you are able to install the REMnux virtual appliance. As I said, you can download, probably that's the easiest way to do it, download it in the open virtualization format, and then whether you're using VMware or whether you're using VirtualBox, you just double-click on that file, and it'll allow you to import it into the proprietary format. Although, keep in mind that there seems to be a bug in Virtual Player where if you double-click on that virtual appliance file, it'll give you an error. So if you're using VMware Player, rather than double-clicking on the file that you've downloaded, you will need to open it using the VMware Player interface itself without double-clicking it. Also, you can use this virtual appliance using KVM virtualization if you'd like. However, keep in mind that if you're using CentOS, you will be unable to use the latest version of QEMU-img convert command because it has a bug in it. You will need to download the latest copy from the QEMU website. Again, if you try to use QEMU for importing this virtual machine, and if you run into any problems, download the latest version from the website of the virtualization software, or send me an email and I'll help you out. All right, so now we know how to get started with REMnux, right? You can download it as a virtual appliance for VMware, VirtualBox. It'll work on Hyper-V, kind of, actually. Let me say that, mention that quickly. If you try to use Microsoft Hyper-V, the virtual machine itself is recognized. However, Hyper-V uses a network interface card that Linux doesn't seem to recognize very well. So I haven't been able to get it running in Hyper-V. If you are able to get it running, I'd love to hear from you so that I can share the information with other people. All right, so now we know how to get started. Let's talk about what is new in REMnux. And again, I'll be mentioning a bunch of tools, but don't worry, I will provide to you all the URLs. All of my notes will be available to you for download after this webcast. We're going to post these slides as well as my full speaker notes about an hour after the webcast ends. So if you don't catch a URL, don't worry, that URL and all the other URLs will be available to you as part of those PDF notes. So changes to the existing tools, not a whole lot here, besides me updating the core packages that comprise the operating system. I also updated tools that you've come to know and love, tools like PDF-ID, PDF Parser, tools like Swift tools, Network Miner, Burp Proxy, Wireshark, Firefox, XOR Search, Density Scout, Pew, too many tools to name here. You can see a full listing of the tools that I've updated if you look up on my blog the article that I wrote to outline what's new in the latest version of REMnux. Some other minor changes that you might want to keep in mind involve me replacing the OpenJDK version of Java with the Oracle version. Oracle Java 7 seems to be supported better than OpenJDK and is more compatible with the tools that I like to use that require that Java be present. You might be familiar with the Origami framework, which is an excellent tool for analyzing PDF files. I've updated that version as well, and there are two minor differences, two minor distinctions that you might want to keep in mind with this latest version of Origami. Let me quickly show you what these are. The first distinction is the way that the PDF extract command works. Now, PDF extract is very handy in that you can point it to a PDF file and it will automatically extract lots of content that is within the PDF file. And most interestingly, you're able to extract the JavaScript that might be embedded into the PDF file. However, the problem that I've discovered with the latest version of PDF extract is that in some cases a PDF file has been corrupted, and so when you run PDF extract, it fails to properly decode the stream and is unable to extract JavaScript. Fortunately, the way around it that I found is to be very specific when calling PDF extract, and instead of saying PDF extract everything there is, instead give it the -j parameter, which means JavaScript, and then even if there are problems with the other objects, as long as the objects that contain JavaScript are okay, it will be able to extract JavaScript. And now in this case, for example, you can see that I have JavaScripts that have been extracted and placed into this file. Again, PDF extract, not a new tool on REMnux, but it does operate a little bit differently when it encounters corrupted PDF objects. Let me get rid of this file just to avoid it messing up my environment. All right, something else that's new in Origami framework, or rather not really new, but it's a nice little tweak. There's a tool that some people like. It's called PDF Walker. And PDF Walker is a tool for interactively examining contents of PDF files. You can look at their structure, you can extract JavaScript, you can extract other objects that might be embedded into PDF files, and you can do this using the GUI. That's what PDF Walker does. The one minor change that is quite nice to this latest version of PDF Walker is that now you can be in any directory and PDF Walker will run properly. In the previous version, you had to be in a very specific directory where PDF Walker was installed in order for it to run properly. So other than that, PDF Walker works as it did before. So we talked about some minor changes to Origami. It's also great that Volatility has been very actively developed, and so the latest version of REMnux now includes the latest stable version of Volatility, version 2.2, and there are a lot of new features, and many plugins have been updated as well, so you really, if you perform memory forensics using Volatility, you want to have this version. Some of the new features that have been added to Volatility 2.2 include the ability to examine event logs. So you can examine event log information that has been captured in memory. There are also a bunch of plugins for examining the Windows GUI. So Windows GUI information is of course stored in memory, and so you can use Volatility now to look at the event hooks that correspond to the GUI interface. You can attempt to gather some aspects of what the screen might have looked like. You can look at clipboard contents. That's pretty cool. Also, this version of Volatility introduces very stable support for Linux memory image analysis, which is quite nice as well. So I'm not going to spend any more time on Volatility because really that would justify its own webcast, and even that's probably not going to be sufficient. But if you're new to Volatility 2.2, take a look at their website to see what has changed. One other minor change, or relatively minor, I guess, from most people's perspective, is that the mind mapping software that I had there before, called FreeMind, is gone. I couldn't get it to run properly anymore, just too many Java compatibility problems. Instead, I'm using XMind, which I think is a better tool, prettier, and perhaps slightly more actively developed. So XMind is there now instead of FreeMind. I don't know how many people will even notice the difference. Now, one way in which you can use mind mapping software on REMnux is to keep track of all of your analysis findings. So as you're examining malware, how do you keep track of all of your notes, all of your screenshots, all of your artifacts? One way to do it is to use the report template that I created on REMnux using this mind mapping format, and of course you can load it using XMind now, and it allows you to have an outline for your future report, and there are placeholders where you might want to save your key observations, recommendations, file hashes, etc. So if you're new to mind mapping, check this out. It's a great way of keeping track of all of your analysis findings. So, we talked about miscellaneous changes to the distribution and some of the more popular tools being updated. This includes updates to Origami, Volatility, XMind, and I also talked conceptually about the need to be able to perform memory forensics, perform PDF analysis, and the way in which many people like to keep track of all of their findings with the help of mind maps. I will be using these tools and concept slides as regular checkpoints throughout this webcast because I'll be covering a lot of tools and a lot of concepts, and my hope is that these periodic slides will help you remember what we've just covered. The next topic that I want to discuss is the tools that I've added to REMnux that make it easier for you to examine obfuscated data where the attacker may have used XOR as a very simple way of concealing strings or binary contents. There are many ways of course, obfuscating data and code, but fortunately for us, many attackers are on the lazy side and use a very specific approach. They basically take a 1-byte value at a random, and that 1-byte value acts as the key. The value can range from 0 to 255 in decimal, and the attacker uses the XOR operator to XOR every byte within the data that they need to protect with that selected key value. And you see this over and over again, whether you're looking at PDF files or web pages or Windows executables. Attackers really like using this approach. And fortunately for us, we've got some tools that can help us examine artifacts and brute force possible key values. So, as I said, I've got slides for every single tool I'm going to talk about, together with all of my reference materials and URLs, but I think it's a lot better to look at these tools in action in an actual REMnux environment. So let me show you a tool that's new to REMnux called XBruteForcer by Jose Miguel Esperanza. Now, this tool is designed for decoding contents of a file using all possible 1-byte XOR values. So, how do you use it? Let's say we've got a file that we want to see whether it contains any values, any data that might have been XORed using that algorithm that I just described. Well, we can tell XOR BruteForcer to examine that file. In this case, I'm using this malicious DLL. And what it will do is it will attempt to decode every single byte within that file with all possible 1-byte long key values and the Boolean XOR operator. So as you can imagine, the output will be huge here. So we might want to say, you know what, I'm going to just extract strings and save them into a file that I'm going to call. Now, as I said, this is going to be doing a lot of work. It's examining every single byte, and it's trying every possible 1-byte long value, and it's using Boolean XOR to create the output. So sometimes this will take a while, depending on how big is the file that you're analyzing. In this case, and again, depending on how much RAM you've allocated to your virtual machine, this will take a while. Oh, one more change, by the way, that I wanted to mention to you is that before, REMnux used to ship with 256 meg of RAM by default in its virtual machine, and I've doubled that now. In part, this is to accommodate the much heavier memory requirements of the Volatility plugin called malfind that seems to do a lot more now but require more memory. So now by default, with the REMnux virtual machine, you get 512 meg of RAM. And if you've got more physical memory, then give it more. The more you give it, the better. Anyway, now that you've extracted the strings, you might want to take a look to see what's the output. Now, it's very possible that the attacker used some other algorithm to obfuscate the data, or maybe he's not obfuscating any data at all. So sometimes all you're going to get is just a bunch of noise. And there's going to be a ton of false positives here, because it's trying every possible key value, and it's trying to decode everything. Now, of course, there's a whole lot of unobfuscated information here. That's what key 00 represents. But then if you go further, you can find data that was obfuscated using key 01. And you're just looking at this. And all I see here is just nonsense, gibberish. So this is probably not anything that's useful here. But I've done a bit more analysis here, and let me just fast forward a bit. It turns out that if you look at key 5, you actually see some strings. Now these strings were not visible in clear text, but this tool was able to brute force the key value, and it's now telling us that there are a bunch of strings here embedded into this executable, and they're protected using hexadecimal key 5. using the XOR algorithm. So that's pretty good. The only problem is that there's a lot of noise in XOR brute forcer. And so you might wonder, is there another way to sift through the strings that are embedded into the file to eliminate some of that noise? And so with this in mind, I wanted to introduce you to another tool that is new to REMnux, and this one is called Brute XOR. Sometimes it's also called I Heart XOR. This is a tool by Alexander Handel. And here is that tool in action, Brute XOR. Once again, you point it to the file that you wanted to examine, and you tell it, give me the strings. Now, what this tool does is it also, just like XOR brute forcer, tries to brute force all possible key values, but it is a little bit smarter at what it is trying to decode. It looks for what might be a meaningful string and only will try to decode those values. And as a result, it runs faster, and you get less noise. Now, there's still a whole lot of noise here, but now, if you scroll through, you will eventually get to something that looks readable, which indicates that indeed it was able to successfully decode some contents. Let's see, it's in there somewhere. And since I've done this analysis before, I know that it's with the key 5. So I'll be able to eventually get to some readable ASCII contents. So now you had 2 new tools added to REMnux that support XOR decoding. One is called XOR brute forcer, the other one is called Brute XOR. Both perform similar tasks, but Brute XOR has a bit more smarts at being able to eliminate some of the noise. Now, you might be familiar with another very popular tool that has been present on REMnux since the very beginning, and that's a tool by Didier Stevens called XOR search. That's a very handy tool. The biggest limitation of that tool is that you had to know what string to look for before you could find it. That's the big limitation of XOR search. But with XOR brute forcer and Brute XOR, as you can see, you don't need to know what you're looking for, as long as you're willing to sift through the noise in the hopes of finding a string that appears readable to you. So, there's one more tool related to XOR operations that I wanted to share with you, and this one is a tool that was written by Glenn Edwards, and it's called No More XOR. Now, this tool attempts to guess XOR key values that are 256 bytes long. So not just 1 byte long key values, but there is some malware that of course uses longer keys. And Glenn Edwards put together this tool to show you how you might be able to find those longer key values. And I want to show you this tool in action by looking at one sample that, as it turns out, actually contains embedded information that has been protected using a XOR key that's 256 bytes long. So let me see. I'm telling it that the output should be saved into this file, and I wanted to analyze pair.doc. Now, this was a malicious Microsoft Word document that was used as part of a targeted attack, and I'm not going to give you, of course, the full background on this, nor would we analyze all aspects of this document in this webcast. But if you've done some work, you might say, there seems to be some embedded code that I can't see in clear text. How might the attacker have encoded it? And you would try a whole lot of things. And if you try No More XOR, it would end up actually trying several promising looking keys, and eventually it will produce what it believes is meaningful decoded object that was XORed within pair.doc using a XOR key that's 256 bytes long. Now you might wonder, how does it know when it found meaningful data or meaningful code? Well, the approach, I think, is quite clever. I mean, think about this from the tool's perspective. You're trying to brute force all possible key values that produces a lot of output, and now a script that's intelligent needs to be able to examine that output and determine whether it's meaningful or whether it's gibberish because this content was not meant to be decoded using this key. So what this tool, No More XOR, does is it uses Yara and it scans the output using Yara, and if it notices that one of the Yara signatures gets a match, it will assume that we must have decoded contents using a proper key. Isn't that clever? In this case, the Yara rule that was hit was embedded exe. In other words, it seems that this malicious Word document contains an embedded executable that was XORed using a 256-byte long key. Now we know what that key probably was. It was brute forced using No More XOR, and we even extracted the embedded data or the embedded code so that we can analyze it further. Now, think about this from the two perspectives. One is it's wonderful to have a ready-made tool available to you for cases like this. But I would say that the value of a tool for which you can view the source code is even more than that. The value of a tool for people who are able to write scripts, who can do a bit of coding, the value is in taking an idea that was implemented as part of this tool and then perhaps taking it further. Can you think of smarter ways of brute forcing key values, of eliminating noise from the output? This approach that Glenn is implementing using Yara, I think, is very clever. Are there better ways? Well, that's why we've got source code to these tools. These are mostly written in Python, but I hope some people in the community will get new ideas from, produce new tools, or give the authors of these tools some feedback. So we talked about a bunch of tools that have been added to REMnux, and these are focused on analyzing XOR encoded data or code. And I talked about the tools that have been added and those tools that have existed there before. There are some additional tools that you might find useful when doing this analysis, such as XOR tool and XXX Swift.py. I'm not going to get into them at this point. I also briefly showed you earlier a text editor that's built into REMnux, Scite. You noticed that I was using Scite to look at the output of the files that were produced. So a bunch of tools that I highly recommend you experiment with and perhaps get some ideas from. The next topic I wanted to cover is a new feature of REMnux that allows you to run Windows tools in the Linux environment. And of course, the full credit for this capability goes to Wine. Wine is what many people call an emulator for Microsoft Windows. In other words, you're able to run Windows tools inside a Linux environment. And while you cannot run the most sophisticated Windows programs within Wine, some of the simpler programs run pretty well. And at this point, I installed Wine within REMnux, and I added two malware analysis tools that a lot of people know, use, and love. Of course, you can add some others if you've got other favorite Windows tools, but the two tools that I'm focused on were Office Mal Scanner and Mozilla. So let me quickly show you these tools in action. Office Mal Scanner is a tool by Frank Baldwin, and it's a toolkit for examining malicious Microsoft Office documents, and it is quite awesome. If you point it to a file that you think might be suspicious, like this malicious Office document, well, it turned out to be malicious, maybe first you want to know info. Give me some info. Is this indeed an Office document or not? Well, it'll parse the file, and it'll tell you that it looks like it follows the Excel structure, and there are no Visual Basic macros. If it found macros, it would have extracted them for you. Now, if you want to look for other malicious artifacts within this document, you use the scan command, and the scan command will look for malicious shellcode. It will look for embedded Office documents, it will look for embedded Windows files, and it will look for embedded Flash programs. In this case, it appears that pair.doc contains an embedded Flash file. And remember, this was the same malicious Office document that I used previously with the help of No More XOR. I extracted what appeared to be embedded binary code. So this is quite a nasty file that you can analyze further if you'd like. Now you might use a tool like SwiftDump, which is installed on REMnux to examine this Swift file. Another component of the Office Mal Scanner toolkit is a utility called RTF-scan. And this one examines files that are formatted using rich text format. So for example, here's a malicious RTF file that I'm scanning using RTF-scan, and I need to tell it what to do. The command should be scan. And now it will examine what is within this RTF file and carve out what appears to be a malicious artifact. In this case, within this RTF file, there is an embedded executable that RTF-scan automatically located and extracted for me so that I can analyze it further. It's very convenient, but up until now, you had to run these tools on a Windows environment. Well now, thanks to Wine, Office Mal Scanner, and the tools that comprise the toolkit can run just natively, or it appears to run natively within REMnux. One other tool that I added to the toolkit, now that we can run Windows programs within REMnux, is Malzilla. Malzilla is a popular tool for those who like analyzing malicious web pages using a graphical user interface. The tool hasn't been updated for a few years, but it's got its fans, and so I thought I'd make it available within REMnux. For instance, you can go to the Decoder tab, you can right-click there to load a perhaps obfuscated JavaScript file that you might want to analyze. Well, let's take a look at this plum.js. Now, the one thing about Mozilla running on Linux is that it presents to you the ASCII contents in a very wide font. I couldn't find a way to correct this. But if you were looking at this using a normal text viewer, you would see that this is an obfuscated JavaScript. And you might wonder, what's so important that it needs to be obfuscated? Well, there are several ways of deobfuscating malicious JavaScript. One way to do this is to load the script into Malzilla. Malzilla, by the way, is written by Boban Spasic. And you click the Run Script button. It will try to deobfuscate it for you automatically. And if you double-click on the results of the run, you get this output. And though it's a little bit hard to read because of the wide font, if you look at this carefully, you now see a URL that is probably malicious that you might want to investigate further. So that's the magic of Malzilla. Lots of ways of deobfuscating JavaScript on REMnux. This is just one tool that is now new to your toolkit. And normally you would run Malzilla on Windows, but hey, now you can run it on Linux if you prefer to do your work within a Linux environment. And so we talked about a bunch of tools that can run on REMnux with the help of Wine, even though these tools are native to Windows, Office Mal Scanner, RTF-scan, and Malzilla. And of course, we talked about the need to know how to analyze malicious Office documents, including Word and RTF files, as well as the need to deobfuscate JavaScript that you would often find within malicious web pages and malicious PDF document files. The next set of tools that I want to discuss deals with utilities that are new to REMnux that allow you to examine Windows executable files inside a Linux environment. Now, there are several tools like this. Some of them have been present on REMnux already, and I'm not going to talk about that. Instead, I want to talk about some new ones. And let me take you into my virtual machine to show these to you. Of course, since you'll be able to download my full slides and speaker notes, you'll have a full set of reference materials available for you, so there is no need to write down your notes if you don't want to. The tool that I wanted to introduce you to you right now is called EXE-scan. EXE-scan, written by Amit Malik, is designed for statically examining a Windows executable. So for example, I'm going to point it onto a file called croker.exe, and what this tool will do is it will examine, well, first of all, capture the hash of the executable. It will then attempt to identify a packer, so it has a database of signatures it can use for identifying which packer may have been used to protect this executable. It will show you the sections of the executable, and very handily, it will examine the import table looking for references to dangerous API calls. And this is one way in which you can examine an executable if you're wondering, is this a malicious one or not, and be able to get a general sense for the capabilities of the program. Sometimes this works better than other times, but it's handy to be able to do so using some static analysis without even trying to run the program. Now, EXEscan can do this quite easily now. There's just this one problem with EXEscan that I wanted you to know about, and it's a strange problem. And the strange problem that I've encountered is that sometimes it deletes the file after analyzing it. I suspect it's some kind of a bug, so keep this in mind. If you're going to run EXEscan, make sure you back up the file that you're scanning before scanning it with EXEscan. Or, better yet, find the bug, fix it, let the author know, and maybe we're all going to be better off. Another tool that I wanted you to keep in mind that's new to REMnux for analyzing statically analyzing Windows executables is PEV. PEV is a collection of several tools that were written by Fernanda Merces for examining various aspects of Windows executables. Now, these are little utilities that are very handy for doing one or more specific tasks. So, for example, if you wanted to calculate a hash of an executable, you can use PE-hash. If you wanted to check whether an executable has been packed, you can use PE-pack. If you wanted to read certain aspects of the PE header of the Windows executable, you can use read PE. So, let me show you some of these tools, not all of them, but at least some of them in action. For instance, let's say we want to use a tool that's a part of this PEV toolkit, and this tool is called PE-scan. PE-scan. And I'm going to say examine this executable file called, let's see, which one should I scan? I'm going to scan kiwi.exe, let's say. Well, we've scanned it, and now we have a general sense for what's within this executable. For example, we can see that it doesn't have any TLS callback functions, which can sometimes indicate that the executable we're scanning is malicious. Well, let's see if this executable is packed. For that, we can use the PE-pack command. Looks like we've identified a packer. It's called armadillo. Okay, very interesting. How about the hash of this executable? Now we've got our hashes if we wanted to use that for some point. And then let's say we wanted to read certain aspects of the PE header of this executable, like the sections and other information. Well, read PE is the command that will give us that information. Now, sometimes you get something useful out of this, sometimes you get no insights at all, but it's handy to know about these various miscellaneous executables that are now available to you as part of the PEV toolkit for analyzing Windows executables from the command line. Now, another tool that I wanted to mention to you that you might find useful for examining malicious code within a Linux environment, this one is called DismThis. It's written by Alexander Hanel. And the tool is designed for locating, analyzing, and extracting shellcode embedded in files. Now, it's not a fully automated tool, so you still need to do quite a bit of thinking, but it will help you determine whether you've found the shellcode or not. Let me show you how you might use a tool like this. I'm going to take you into my environment. Now, for this sample, I'm going to be looking at a malicious Flash program called mango.swf. And one way in which you can analyze Flash programs is to use a tool that's a part of REMnux. It's not new. You've had it before. It's called SwiftDump. I can use SwiftDump to extract a whole lot of information about a Swift program and save that into a text file. Let's use SciT to examine the output of SwiftDump. And what I'm doing here is I'm looking for any kind of an anomaly. For example, look at this. There's a tag that's built into this Flash program called define bits JPEG, and you're supposed to use this tag to embed a JPEG image inside the executable. But this does not look like an image because it has references to various ASCII strings like executable names and URLs. So most likely this is not an image at all, and I'm theorizing that maybe this is shellcode. And now the question is this indeed shellcode? And if it were shellcode, how would I disassemble it to analyze its capabilities. Now, it might take a bit of time to examine this blob of information to determine where might shellcode arise. For example, here I see a bunch of 90s that follow CCCCC, and so I would form one theory that the shellcode begins here at 1990-60. Now again, just a theory, and we don't really have time at all within this webcast to talk about how in great detail you would find and analyze shellcode, but I do want to show you a bunch of tools that can assist in this process. For example, there's a tool called REDair that has been a part of the REMnux distro for a while, and REDair is a very handy command line hex viewer, editor, and disassembler. For example, you can tell REDair using the -x command to look for the following sequence of hex bytes within the executable, and it finds them and it creates a bookmark for them called hit01. Then I can go there and I can say, why don't you show me, print what's there and disassemble it. And I'm saying disassemble 30 commands. And now I've disassembled what I think is shellcode, and now if I know how to read assembly, I can determine whether this is indeed shellcode or not. So this is some shellcode analysis using tools that have been a part of REMnux for a while. And the tool that I wanted to show you in this context is new to REMnux. That's what I mentioned earlier. It's called dism-this. And dism-this allows you to look at where you think shellcode began. And though I cleared the screen quite quickly, REDair showed me that it thought the shellcode begins at the offset 3E. And I can say, why don't you disassemble 36 bytes there, and not only try to disassemble that shellcode for me. I could see this in REDair, so this in itself is not new. What's nice about dism-this is that it also shows you the results of some analysis, where it tells you some information about what it had just disassembled, so that you as a skilled analyst can determine whether this is indeed shellcode, or maybe you're just trying to disassemble some junk that's not shellcode at all and is not meant to be disassembled. So how can you make that determination? What the tool does is it counts for you how many infrequent or rare instructions were seen. The idea is that if you're trying to disassemble a set of bytes that are not representative of instructions, if you're trying to disassemble something that's not meant to be disassembled, then you're going to encounter a whole lot of unusual, infrequent instructions. And that would be your indicator that you're not looking at the right place. Similarly, the tool counts references to segment registers, which should be rare, as well as references to static offsets, which should be rare unless you're examining shellcode. Now, this tool sometimes works very well. Sometimes the information that it gives me isn't all that useful, but the idea is wonderful. Perform some automated analysis that gives an analyst a few metrics that the analyst can use to determine whether he or she is looking at the right place of the malicious file. And that is quite a wonderful idea that I think warrants some more experimentation. So staying within the context of examining malicious Windows executables in a Linux environment, I wanted to introduce another tool to you called DFIR tool. And it's written by DDA Stevens. And this tool is designed to manipulate digital signatures embedded in signed Windows executables. Now, you may have seen the trend that a lot of targeted attacks involve signed executables. In some cases, attackers have been known to steal a digital certificate from one company and use it to digitally sign their malware. And if an executable is digitally signed, it is much less likely to be blocked by our anti-malware tools. So let's say you've got this executable and you're wondering, is it actually digitally signed at all? Specifically, I'm examining for this sample the executable kiwi.exe. Now here's one way in which you could determine whether the executable is digitally signed on REMnux using tools that have been installed on REMnux before. The tool is called Pew, and Pew is a command line tool that is a hex editor designed specifically for malware analysis. And I'm going to load Kiwi into Pew. Now, Pew has a lot of capabilities. I'm not going to get into all of them. You should definitely check out Pew on the web if you're new to this tool. But what I want to use Pew for specifically is to look at a particular data structure within the optional PE header fields. So I'm going to say Pew, show me contents of the PE header, and I'm looking specifically in the area where I know there should be an entry related to digital signage. The header is called optional_header dot data directory. And by the way, Pew is wonderful in that if you start typing, you can press tab and it will autocomplete. Now, this is the data structure within the PE header that contains a lot of fields, and the one that I'm looking at, or the one that I'm looking for, is called security. This is the field that should contain a pointer to the digital certificate that might be embedded into this executable if it were digitally signed. And here I have the security entry within this structure, and I'm looking at its size. If it's a non-zero size, then most likely this executable has been digitally signed. So this is how you can look at a Windows executable using Pew to determine whether the executable has been digitally signed or not. Look at contents of this field within the PE header and look at the security data structure to see if it contains a non-zero size. But there's a better way now. There's a better way thanks to the tool that DDA created, and that tool is called DCIT tool. So DCIT tool can extract digital certificates from malicious files. Now, if you point it to a file that has not been digitally signed, let's say I pointed to, Hubert DLL. Well, it's not digitally signed, and it gives me an error saying that, yeah, I couldn't do that. File source is not signed. But if I point it to a file that turns out to be digitally signed, in this case Kiwi, I'm going to say save the output into kiwi-sig.dir. No error. No error means that it probably was digitally signed, and this tool was able to extract the certificate. And it uses the DER format for creating the resulting file. Now, you can look at the resulting file using strings, and you can learn a whole lot about who the certificate might have belonged to and who it was digitally signed by. But here's a command that you can use to take that DER formatted certificate and convert it into a text file. This is hard to remember, I know, but don't worry, as I said, you're going to get full slides on my speaker notes as a follow-up to this session. So I'm using OpenFSL to convert that dir formatted file into a text file. And now if I look at it, I can actually read contents of the digital certificate that we extracted from this Windows executable. And that's pretty handy. So I talked about a number of tools that have been added to REMnux for the purposes of analyzing malicious Windows executables statically while staying within the Linux environment. And here's just a summary of all the tools that I had mentioned. Some of these are new to REMnux, some of these have been there before. The best way to get to know these tools, of course, is to experiment, which is why I hope you download that malware archive that I'm using for this demo and experiment while being careful not to inadvertently infect yourself. But there are some other tools that I couldn't categorize under any other heading but other new tools that I wanted to tell you about. A bunch of other tools that I think you will find pretty useful, so let me talk about those. The first tool that I want to mention to you is called AutoRule. And AutoRule is a tool by Jacqueline Correa. And AutoRule is designed for examining a set of files and automatically extracting binary patterns from those files to create signatures for them. And it will use the Yara format for creating signatures. Let me show you what this tool looks like in action. So let's see. The tool is installed on REMnux. To run it, you type user local auto tool tester. Then you point it at the location where a bunch of malicious files reside. And your hope is that these files might somehow be related together so that there will be one or more signatures that the tool will automatically create for you for automatically spotting these types of files in the future. So what I have here is a bunch of samples that I obtained from the set of files that Mandiant analyzed when it was publishing its report called APT1. Now, Mandiant classified these as a set of malicious executables called mappyget. And I've got two of those files in this directory that I'm now pointing tester.py to. And now the tool runs and it digs those files and it automatically creates this set of Yara signatures for me and generates the rules. Now, of course, what I should have done is actually save this into a file. I'm going to call this mappyget.yara, and my hope is that what I've just done is created a signature for this malware called mappyget. Now what I can do next is point Yara, which is a tool that has been a part of REMnux for a while, and Yara is a signature scanner. I'm going to tell Yara to use this signature that was just automatically created, and I'm going to tell it to examine another directory. Now I've got another couple of mappyget files that I obtained from Contagio, another source. Notice that I generated this signature by scanning one set of mappyget files, and now I'm telling Yara to examine another set of mappyget files, and I'm checking to see whether the signature will work. Well, look at this. It was able to scan contents of this folder that contains two executables, and it successfully identified one of those executables as yet another mappyget variant. Now, there are actually two mappyget variants there, so the automation isn't perfect. There is one mappyget file that it failed to identify, but still it's pretty good. It's pretty good, if nothing else, than to demonstrate this concept for automatically generating signatures in the Yara format. Now, I think of this particular tool, AutoRule, as a proof of concept. It does produce a lot of false positives, especially because as part of its signature, it oftentimes includes a set of consecutive 0 bytes, which are very common in files that are executables and PDF files and Word documents, so a lot of false positives. But as a concept, it's very nice and something that you might be willing to take and then improve upon. That's how we all get better, right? Somebody gets an idea, creates a tool, we either contribute to that tool or write our own tool that expands upon that idea, and in the long term we're all better off because now we have a bunch of tools that can help us do malware analysis better than we could, let's say, a year ago. All right, well, what else can I show you about REMnux in the miscellaneous category? Well, there's one handy tool that I really like. It's called XIF. XIF is a tool by Phil Harvey, and XIF tool is designed for reading, writing, and editing meta information in files of all sorts of different file types. Now, this tool is probably best known for accessing meta information within image files like PNGs and JPEGs and GIF files, but it can handle many more formats relevant to malware analysts as well. For example, look, I can point this tool to a Word document, and it tells me that this is a Word document and gives me some meta information about it. Or I can point this tool to a Swift file, and it tells me a whole lot of information about this Flash program. So not a big deal, I suppose, in the grand scheme of things, but very convenient to have this tool called XIF tool to gather meta information about the files that we're examining. Now, if you think about the kinds of tools that I've been showing to you, I've been talking about a lot of static analysis tools, a tool that can locate obfuscated contents, a tool that can extract meta information, a tool that can extract certificates. wouldn't it be nice if we could just automate the execution of those tools? And that's what we can do with the help of a framework called Mastiff that was created by Tyler Hodek. And Mastiff is designed as a framework for automating static malware analysis. Now, the version of the framework that's a part of REMnux is a little bit old, because last week or so, Tyler released an updated version of this tool. In the instructions for in the instructions for, or rather in the notes for this webcast, I will give you very detailed instructions for how to update your distribution of Mastiff to get the latest and greatest version. But I've taken you to a snapshot that I've already created where I have the latest version of the toolkit. And now let me just quickly show you how to run it. I'm going to say mass. That's how you run the Mastiff toolkit. Then I pointed to user local etc mastiff, which is the config file that's present on REMnux, and then I pointed to a directory that I want to scan. Now this tool can scan a whole lot of files. It has a built-in queuing mechanism, and the wonderful thing about the Mastiff framework is that it is trying to be very smart about applying only the appropriate plugins for statically analyzing executables, or other files, given that file's file type. So if it determines that it's examining a Windows executable, it will use one set of plugins. If, on the other hand, it determines that it is analyzing a Word document, it will use another set of plugins. So what you get as the result is a set of information that has been extracted from the files, but the information is relevant for that specific file type. And so if you want to see the output of Mastiff, on REMnux you can go under var log Mastiff, and this is where you can see it saving the output of its run. Now, you can go into any one of these directories. Let's look at, see. There's this one file, let's say this one. And we can see that it copied into here the executable that was scanned, and it pulled out a bunch of information using PE info, and check this out, it was even able to extract the digital certificate that you might recall we previously located as being embedded into this file. So just one example of the kind of information that you can get using Mastiff in an automated manner. Very handy for analyzing a large data set. Now, there's one other tool that I wanted to mention to you, and this is a tool that you can use for, well, making sense of the data that you've gathered on a Windows system. So ProcDot is the tool, and it's created by Christian Wozner, and ProcDot is designed for correlating data that was captured by Microsoft's Process Monitor tool with the contents of a PCAP, packet capture file. The idea is you would infect a Windows system with a malicious executable while having Process Monitor running and while having a network sniffer running like Wireshark. And then you can load those log files into ProcDot, and it will create an interactive color-coded graph that highlights the meaningful events and lets you navigate that data visually, which in many cases is much more effective than navigating the flat text-based log file that you might have gathered using Process Monitor alone. And ProcDot is installed on REMnux, although today Christian released the latest build of this tool. So if you're using REMnux, you might want to update your copy of ProcDot, and in the notes that I'll make available to you after this webcast, I will have very detailed instructions for how to very easily update your copy of ProcDot. Once you launch it on REMnux, you'll be able to load the procmon, or process monitor log file, load the PCAP file, and then it will generate the graph for you that you'll be able to analyze. And then, perhaps lastly, as we are running out of time, I wanted to mention a number of one-off functions that are available to you now thanks to some work by Fernando Merces. He created what he calls hack functions, which are just a bunch of bash shell functions that you can use in your terminal window on REMnux. Now, these functions are not loaded into your environment by default, but you can use the source command on REMnux to load those functions, and now you can perform a whole lot of operations right from your command line. And these operations include the ability to convert from one decimal base to another. You can convert characters and strings across various encodings. There are some functions specific to obfuscation and encryption. Lots of different functions, perhaps too many for us to go through on this webcast, so I'm not even going to try. Instead, I'm going to point you to the reference page that is available on REMnux. The original instructions were in Portuguese. I used, I think, Google Translate to convert them into English for those of you who prefer to read in English. So definitely check out these functions. They might save you some time as you perform your work on the command prompt. And so, as you can see, lots of tools built into REMnux, including those that I would classify as being in the miscellaneous category, including autorule and exif tool and mastiff and procdart and head functions. And of course, I've also mentioned some other tools that have been present on REMnux already that I highly recommend you experiment with. And this is as much as I've prepared for you in terms of providing an overview of the tools that are built into REMnux that are new to the latest release of REMnux. The best way to learn these is to experiment with malware and experiment with these tools, and I hope that I've provided you with a starting point for getting to know REMnux and becoming a better malware analyst. Now, if you're interested in becoming better at malware analysis as well as other aspects of malware forensics, well, I suggest you check out the various webcasts that SANS has put together. Some of these have been previously recorded, others are coming up over the next couple of months, so check out this link to the malware-related webcasts. Also, if you're new to REMnux, definitely check out the checklist or the cheat sheet that I put together that documents some of the most commonly used commands on REMnux. And of course, my hope is that if you find this topic interesting, then perhaps you will attend the reverse engineering malware course that I teach together with my colleagues at SANS Institute. And of course, we make heavy use of REMnux as well as various other tools and techniques throughout the course. And so, folks, this is all that I've prepared for you. I will stick around to see if you've got any more questions. Otherwise, please feel free to reach out to me by email and Twitter, and I hope to see you at one of the SANS events.
At this point,
soon.
I'd like to start the Q&A session for the webcast. Lenny, the first question is, what's the best way to transfer malware files between Windows 7 host and REMnux VM? Couldn't set up shared folders in VM, assuming networking could be host only.
So there are several ways of transferring files in and out of the REMnux environment. By far, my favorite way of transferring files in and out is to use SFTP. And this way you don't have to deal with NetBIOS, you don't need to set up shared folders, even though I suspect you can do something like that. But I've never really tried, and in fact I don't even think Samba is installed on REMnux, so I'm not sure shared folders would work. My recommendation is to use the SSHD daemon that's installed into REMnux, and first you would need to do SSHD start, not stat, SSHD start, and then you would use a tool like SFTP. There are lots of SFTP clients to get files in and out of REMnux. I think that's the best way to do it, and that's what I typically do. And again, it's all about the convenience and your working style. Maybe you prefer something else, but I suggest checking out SFTP.
Okay, the next question is, does REMnux contain any tool for Android malware analysis or mobile malware analysis in general?
REMnux has not been designed specifically for analyzing Android malware, and in part it's because I frankly don't have the expertise to go beyond a few very basic steps when it comes to analyzing Android malware, and some of that has to do with just decompiling the Java files that oftentimes comprise Android-based malware. And on REMnux there is a very handy Java decompiler called JAD, and another one called JD-GUI that you can use for that purpose. But for performing further malware analysis of REMnux, or rather on REMnux of Android malware, let me see, there was just a write-up that I saw, that I posted on my Twitter stream a couple days ago. Hold on a second. I can't find it anymore, huh? It's in there somewhere. Ah, there it is. Hold on. Let me share the link with everybody. So this is a little write-up that was put together by Angel Alonso Marizas, and he took REMnux as well as another Linux distribution that's maintained by several SANS instructors, mainly Kevin Johnson, called Misc. And he showed on that write-up how you can bring up a REMnux virtual machine for emulating some services. And then he brought up the Misc virtual machine, which is designed for analyzing mobile code, and then he used the two distros together to analyze mobile malware. So maybe that's something that would be of interest to you.
Okay, our next question is in general. Is the VMware REMnux corrupted? I tried to download it, I'm getting errors, I'm trying to extract the files.
If you're trying to download REMnux and you're getting errors, then not sure what I can assist without knowing which specific errors you're getting. I can tell you that I've been able to successfully download all files and be able to extract them. I would check the MD5 hash of the files that you're getting, and you can download the REMnux files from SourceForge. And if you look at remnux.org, I list there the hashes of the files that you should be able to get. And if the hashes don't match, then maybe there's a file transfer error somewhere. Also, it could be a problem with the extraction utility that you're using. So if you're using something like WinZip, try something like 7-zip perhaps to see if you get better results. Otherwise, if you're trying to download, let's say, the proprietary VMware formatted version of the virtual appliance, maybe instead try to use the open format virtual machine to see if that one works better for you.
Okay, our next question is, I am sure, like the others in the field, that I'm not the only person who has built handy scripts. How can we as peers share the tools we create for possible inclusion into REMnux?
You know, that's a great question, because it comes down to the challenges that anyone has, any community, whether it's security or butterfly enthusiasts, about how do you exchange knowledge and improve by jointly collaborating on projects. And it's oftentimes hard to do so. And in many ways, what I'm trying to do with the REMnux distribution is act as a, I don't know, as a funnel mechanism, so that whenever people create wonderful and useful tools, I try to do my part by spreading the word around them, about them, and documenting them in my blog sometimes, and including them in REMnux. But to answer the question very tactically, if you created or know of a tool that you would like to recommend for including in REMnux, just send me a note. And I'll take a look at it, and if it works as advertised, and if it fits the objective of the REMnux distribution, which is malware analysis, then I'll gladly include it. So please send me a note on Twitter or by email.
All right, the next question is from an instructor. Do you know of any good exercises that are progressive in difficulty, which I can use as background for training folks in analysis? Finding
exercises for educating people about malware analysis is difficult and time-consuming. That's because there's a whole lot of malware out there, but finding a sample that doesn't overwhelm the student and only shows what is relevant and doesn't leave much room for distractions is hard. I don't have any specific sources in mind besides just looking for malware and analyzing it, and just a whole lot of time spent on trial and error, unfortunately. Otherwise, I don't know if I could point to a set of challenges that could be used for this purpose. It's just a bunch of trial and error and finding that sample that demonstrates specifically the point that you as an instructor are trying to make.
And for our last question, has the REMnux cheat sheet been updated recently?
I have not had a chance to update the REMnux cheat sheet to include the new tools that I've added to version 4 of the distro. And it's something that's on my to-do list. As you can see, there's a whole lot of tools, that I want to include there, but I just haven't had a chance to do so, but hope to be able to do so in the next month or so. Thanks for the reminder, actually.
It appears we have one more question. What is a good piece of malware to start analyzing for a newbie?
A good malware to start analyzing for a newbie? Well, it depends on where your strengths are and what aspect of malware analysis is most interesting to you, and my recommendation would be to start with that aspect that is easiest for you, the one that builds upon the strengths that you already have, and that kind of sample and that kind of area is going to be different from one person to another. But I can point you to a webcast that I recorded earlier that talks about one sample, and I walk you through the various steps of examining that piece of malware using OLEdebug. And let me see if I have a link to that recorded webcast. It's called something like Getting Started with Malware Analysis. Oh, there it is. Hold on, I found it. So this is a webcast that I recorded a while back, and my recommendation is to use that particular sample that I'm analyzing. And if you need a copy, send me an email. And maybe that's a good starting point for you. Again, depends on where and strengths are. Another starting point might be the various samples that I talked about in this webcast. And you're welcome to download a copy of that malware archive from the URL that we'll make available to you as part of the notes shortly after this webcast ends. And also, I did conduct another webcast that introduced people to malware analysis using REMnux, and there I mentioned a whole other set of samples that you might want to start experimenting with.
All right, it appears we have one last question. Are there any tools on REMnux that specific checks for VM detection routines in PE and DLL files?
So there are several tools in REMnux that perform some static analysis of malware, and they look for risky Windows API calls. I mentioned a couple of tools like this on this webcast. Another tool like this is called PE Scanner that can identify suspicious DLL or the suspicious API calls. However, for detecting virtualization itself, you would need to look beyond API calls, and you'd want to look at a set of specific assembly instructions. And all of that is to say that I don't have a specific tool like that that knows to look for that particular pattern or patterns. You've got tools that look at API calls, you've got tools that look at strings, and sometimes you can tell that malware might be looking to identify security tools by just a set of strings that you see embedded into that executable. But looking specifically for ways in which virtualization is detected, not that I can think of.
All right, that will conclude our Q&A session. I'd like to thank you so much, Lenny, for your great presentation and for bringing this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.